Welcome back! Derivatives of trig functions. We are going to start with two proofs. What better way to start the day? Woohoo! Here we go. I want to prove that the derivative of cotangent is negative cosecant squared. First thing we should do is rewrite using a fraction, and then we can use the quotient rule. So, cotangent is cosine over sine. For these proofs, we're going to already use the fact that the derivative of sine is cosine and the derivative of cosine is negative sine. So we're already going to know and use that information. It is a true fact. So quotient rule, I'm going to do the derivative of the sine. No. Sine times the derivative of the cosine minus cosine times the derivative of the sine all over sine squared. Quotient rule. Okay, so the derivative of cosine is negative sine, so that's negative sine squared x. The derivative of sine is cosine, so that's going to be negative cosine squared x over sine squared x. Okay, factor out the negative 1. Very easy to do when you have a whiteboard. And this becomes negative 1 over sine squared x, which is indeed negative cosine squared x. Okay, so that is the proof of the derivative of cotangent is negative cosine squared x. Now we're going to do the derivative of cosecant. I said cosine, I meant cosecant. The derivative of cotangent is negative cosecant squared. I think I may have said that wrong. All right, now we're going to prove that the derivative of cosecant is negative cosecant cotangent. I hope I remember that correctly. It's been a long time since I've done derivatives of trig functions. So this is 1 over the sine. Okay, so quotient rule again. This is going to be sine times the derivative of 1, which is 0, minus 1 times the derivative of sine, which is cosine, all over, sine squared x. So this is negative cosine x over sine squared x. So that's negative cosine over sine times 1 over sine. Negative cosine over sine is negative cotangent. 1 over sine is cosecant. Okay. So for the the six trig functions and their derivatives, you need to know those without a book or a note card or whatever. You can always derive them if you want. That always works. Okay, so now I'm going to take a look at number 22, where you're asked to find the equation of the tangent line and the equation of the line that's normal to the tangent line. So normal means you are perpendicular. So the normal line is perpendicular to the tangent line. So that's opposite reciprocal slope. So the problem says, find the equations that are tangent and normal to the graph of y equals secant x at x equals pi over 4. First thing I'm going to do before I find any derivatives or any slopes is I'm going to look at what's the point on the curve. So if x is pi over 4, The secant of pi over 4 from your unit circle is root 2. Okay. If I want to find the slope of the tangent line, I need to find the derivative. So the derivative of y with respect to x of the secant is, I believe it's secant tangent. Yeah, secant tangent. Okay, so this is the slope of any tangent line on the curve of secant x, but I want to know specifically at pi over 4. So at pi over 4, the slope of the tangent line is the secant of pi over 4 times the tangent of pi over 4, which when you work this all out, I believe, I did the work ahead of time, I'll post a PDF, is root 2. The normal line the slope is going to be negative 1 over root 2, which is negative root 2 over 2. I have a point. Here's my x1, y1. I have my slope. I have my slope. We're just going to write two equations of lines. So the tangent line is y minus root 2 is equal to m, which is root 2, times x minus pi over 4. And the normal is y minus root 2 equals negative root 2 over 2 times x minus pi over 4. It's exactly what you were doing with tangent lines like last chapter. The difference is, same process, the difference is now there are trig functions instead of being, x squared or 3x or whatever. Okay, last thing, a jerk. I bet you didn't know that there were jerks in mathematics other than, the ones that you don't like in your math class. Okay, so a jerk is a sudden change in acceleration. So you're driving in your car and a squirrel, crosses the road and you slam on your brakes. That's a jerk. When a roller coaster is a fantastic example of a jerk. You're going up, 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 and then it slows down and then whoosh, off you go. I hate roller coasters, and that's exactly why, because of all those jerks. So a jerk is a sudden change in acceleration. How do you find it? Yet another derivative. It's all it is yet another derivative. Okay, so let's hope this marker works. It does. J of t is some function representing the jerk at some time t, is equal to the derivative of the acceleration, which is equal to the derivative of the velocity, which is equal to the derivative of the position function. So the jerk is equal to the third derivative of the position. The problem is, if you get the velocity derivative incorrect, and then the acceleration derivative is incorrect, and then your jerk derivative is incorrect, so you have to be super careful that you don't make a careless mistake. So take your time so that you don't have this overall incorrect derivative equation. So let's start with, let's do 1 plus cosine of t. I didn't leave myself a lot of room. And I want to know the jerk function, which sounds really strange, but okay, so I'm going to do it up here, sorry. So the velocity function is equal to the derivative of the position function. Well, the derivative of 1 is 0, and the derivative of cosine is negative sine. Derivative of cosine is negative sine. I have a funny story. So I was in calculus class in high school, and I was a good student, and blah, 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 and I could never remember if it was sine was negative cosine, like I could never remember where the negatives came. So my really good friend sat behind me and he cheated off my paper. And on my paper, I got it backwards and he corrected my mistake and he got a higher grade than I did. I was so pissed off. Anyway, the moral of the story is make sure you're cheating off the right people. All right. No, the moral of the story is you shouldn't cheat at all. You should learn your trig functions. You should learn that the derivative of sine is cosine and the derivative of cosine is negative sine. All right, acceleration function is going to be negative cosine. Acceleration function is negative cosine. Derivative of sine is cosine, and then the negative comes down. All right, so the derivative of cosine, so you have the negative, and the derivative of cosine is negative sine, which is sine. You have, and I started with 1 plus cosine. Is that what I started with? I'm pretty sure. Yeah, I think that's what I started with. Negative sine, positive sine, negative cosine, positive cosine. Just a little quick review. 1 plus cosine. There's your cosine curve. You probably can't see that. Let's do it over here. That's your parent cosine curve, but it's 1 plus, so it's shifted up 1. So your sinusoidal axis is now 1. So we're at 2 and 0. Oh, it should touch. Let's try that again. If you're bored or you're annoyed and you want to turn off the video, feel free, because I'm done doing new stuff. There we go. Your amplitude is still 1, but the whole graph has been shifted up 1, known as the sinusoidal axis. All right, that's it for chapter 3.